Now I've taken those 16 steps into a flow diagram. In this particular way here, I can begin to see the interaction and the effect each milestone task has. And if I get that wrong, then that machine will fail earlier, sometime in the future. If that's not done right, or I leave it out, or it's very clear now. That's a series process. At the end here is meant to be a long-lived machine with 5 or 6 or 10 years trouble-free operation. And I don't do that well, or I don't do this well, or I don't do any of them well. I'm never going to get my 5 or 6 years. So to help my people, to help my company, and to do the right thing, I should also tell them how to go about getting 5 or 6 years trouble-free operation out of your repair job. But that's not given to them. They're only given that. That's all they're given. The rest they work out for themselves. Now we overcome that problem with one more step. We actually write job procedures. So job plans do not deliver job quality. For that, you need detailed job procedures and proof tests throughout the rebuild activities. So this 16-step job plan, when we turn it into a procedure, let me show you what happens. Okay, that's that conveyor pulley there. This is a bit of an intro on some information in the workbook. I then go into actually the details of the job itself. I include all the parts and materials and tools they need. I leave that particular diagram in there. I don't expect planners to convert their job plans into a flow chart. I'll leave that there in the example to make the point that all of these are important. There isn't one here that I can afford to do wrong and expect to get 5 to 10 years trouble-free operation out of my machine. But that's only the job plan. Now I'm going to do the job procedure. So I start at task 1, which is done by the technician. It involves preparing for the job to make the area safe and clean and trouble-free. And I work my way through this entire job. Remember, those 16 milestone tasks all have to be achieved. We just don't know how they're going to do it. Now, the guy will do it the way he thinks he's okay to do it, which is what he learnt in the last 20 years off 15 other guys. That's what's going to go through his head. But it isn't necessarily the one best way. It might be the one best way. I mean, luck can be in our favour that day, but it may not be. So we take that job plan and I start doing a job procedure. So bring this a little bit bigger. So that, the guy will have to measure the shafts, record measurements, check the shaft is actually round and cylindrical, sufficient for the bearing. He's going to have to do that at different parts of the shaft, both ends of that shaft where the pulleys are. You're going to check the parts of the correct parts. Oh, there's calculations required to get the interference, to get the clearance right in the bearing. He has to do a mathematical calculation to make sure that he sets up that clearance with feeler gauges. So as soon as he sees the calculation there, we know from human error rate tables, some guys are going to miscalculate. Guaranteed to happen. So how do I help my guys get it right is an issue that a planner will have to do. My 16-step job plan said nothing about the calculation required to set the clearance. Gee, I hope the guy knows what he's doing, can do the calculations, understands mathematics well enough to do that job properly, because I never told him what he has to do. Oh, his years of experience, the 30-year man, he'll know what to do. Well, I hope he does, because I don't know what to do. There will be tables to select clearance values from, depending upon the size of the bearing, different clearance between the internal components. Gee, I hope he gets the right line. I mean, there's, hope he picks the, gosh, I won't be there. Nobody else but this guy will be there. I hope he gets it right. There he is. He's going to have to check the clearance. It has to be spot on because I want to get 5 to 10 years trouble-free operation. And we go on down. Oh, look, another measurement. This is for the base plates. More measurements. Oh, this is for driving up the taper sleeve on the shaft to get it in the right position so that when the bearing finally is bolted into place, the clearance comes right. Hope he knows what he's doing because I don't know how to do it. I hope he does. And on we go. This is the detail. These 16 steps on his job plan, the guy has to do all this. To get to the end of the 16 steps, he has to do all this and get every single thing right. Out of his memory, out of his memory. Base plates, alignment, flatness, installation, positioning, greasing. Gee, is it even the right grease? I didn't say on my job plan about getting the right grease. I hope he knows what grease to use. It didn't say what to do. Just, he knows what to do. I don't know. I hope he does. We go on down. Oh, look, I've got to assemble it properly, install it properly. I'll get the alignment of the shaft so I don't damage the seals. Because if those seals are damaged, all my rubbish goes in there and I won't get 5 or 10 years trouble-free. I'll get full of water and it'll be down again in 3 months. 75 tasks to do those 16 milestones. Do you think any human being in the world can go through 75 tasks out of their memory? And yet this is what we asked him to do. We gave him a piece of paper. Please do this job. And of course he goes. That's his job. I will do that job. I could never get it right, but you give that to me and say, Mike, off you go. I'll do the best I can. I'm an engineer, mechanical engineer. I'll have a damn good idea of what I'm meant to do, how accurate it has to be, how perfect it has to be to ensure that the outcomes are not like this, but like that. I need to be here all the time. I've given the guy a process that automatically guarantees ongoing failures because it doesn't tell me how to do it. How do I control it to be there all the time? If I can do that, then this disappears. I can stop this rubbish going on, but I've got to write the documentation. I've got to write this. Without that, nobody can win. Oops, let me get this right. Get to it first, there we go. So yes, procedures, absolutely vital, because that's the how. That's the how to get the distribution right every single time. And without the how, I just hope it's my lucky day. Now I'm running on luck. My whole business is running on luck. Go find good. And what they say these days, of course, is the people make the difference. Get the right people for the job. Of course, you get competent experts, you get brilliant guys, 1 in 1,000 guy that gets it right every time. How are you going to find that guy? How are you going to keep that guy? Well, I've got to build a business process that doesn't matter who the guy is. Just follow the rules, Fred. Larry, just follow the rules, mate. Here it is. You don't know how to do it? I'll take you to school and we'll get you to do some bearing installation training. And we'll make sure you're good enough to come back to work and do this job properly. I can build a company to do all that. Why would I bother? Well, it all depends what that costs. Because that's money I'm throwing away because I haven't got a process to guarantee the quality that gives me the reliability I need. For 20 years, I just did the same thing as everybody else.